Buonasera a tutti. A nome del comitato organizzatore di Festivaletteratura ringraziamo Tea per aver contribuito alla realizzazione di questo evento e diamo il benvenuto a Joseph Ledoux. Presenta Maurizio Matrone, Accenti.
Bene, buonasera. Come avrete letto nel cartellone, questo è un accento in lingua ed è in lingua inglese, quindi sarà assolutamente in lingua originale, non c'è un traduttore. Quindi per quei pochissimi che come me alle medie hanno fatto francese, dovrete prestare molta più attenzione. Gli abbiamo detto di parlare lentamente, di modo che sia più comprensibile, più facile, anche perché i temi sono piuttosto importanti. Quindi sarà un accento un po' sdrucciolo, essendo la lingua inglese, però il tempo è sempre quello, 30 minuti, non più di 30 minuti e alla fine ci sarà modo di comprare i libri nel banchetto che c'è qua alla mia destra e lui potrà autografarveli qui. Bene, buon accento e buon ascolto. Grazie. Thank you.
So thank you, and thank you all for coming. Tonight I'm going to be talking about fear and anxiety and how these work in the brain. But I want to start with some general introductory remarks about the brain and how it works. So there are certain things that we accept about the brain for those of us who work in the field of neuroscience. The most basic one is that all aspects of mind and behavior are products of the brain. Now, we can study the brain and we can learn things about human nature and improve human well-being by studying this organ. And as a starting point, let's talk about how we think about the brain. Well, especially when we're thinking about psychology, there are three fundamental questions: what, where, and how. The question of what is it you're interested in, whether it's anxiety or memory or perception. Where is, of course, where it's located in the brain, and the question of how is what are the cells and molecules underlying that process doing. So the usual approach is to think about this in terms of reduction, where you start with behavior and you work all the way down to the level of cells and circuits and synapses and molecules. But my preferred approach is to think about integration. So we're not talking about how to explain behavior in terms of molecules, but molecules can also help us learn something about behavior itself. In the same way with cells and synapses. They can inform molecules, molecules can inform cells and synapses and molecules can all inform in behavior. So these are different levels or different ways of thinking about the same thing. The goal is not to eliminate psychology, but to embrace it within neuroscience. Now, we often hear about neuro this and neuro that, and to some extent, a lot of what we hear about is what we call neurification, which is the falsification or creation of something that doesn't necessarily exist. We have all sorts of scientific and academic and practical ways of thinking about this. We even have, things like neurospirituality, neuro happy hour. Is this wrong? Well, it's not really wrong. It's just that we need to be careful about what we're talking about when we talk about these things. So, some things that we can consider hype are, is the left brain rational and the right brain artistic? I don't necessarily subscribe to that. You may have also heard that dopamine is the chemical of pleasure. I don't subscribe to that. Brain imaging can read minds. I don't believe in that. And the one that I especially don't believe, but I'm often associated with, is that the amygdala is the brain's fear center. And that's what I want to kind of talk about tonight. So I've studied this part of the brain, the amygdala, for more than 30 years. And it's gone from being an obscure region of the brain to practically a household word. Probably almost everyone in the audience has heard of the amygdala, but 10 years ago you may not have. So in popular culture, there's a Batman cartoon about the amygdala. This monster is called the amygdala. There's a Facebook page for the Amygdala Cafe, which I think is in Italy, by the way. There are T-shirts you can purchase, amulets and bags and all sorts of things. There's a YouTube video by Svungel called Tickling the Amygdala, and on and on. So there's nothing really wrong with all of this, but as a scientist, we want to know what exactly this part of the brain is doing. So let's start with where it is. So if we shoot an arrow into your head through your ear, and it's going into this ear, and then we put another arrow into your right eye, where they would intersect is roughly where the amygdala is in your brain. What does it look like? Well, many years ago, hundreds of years ago, an almond-shaped structure was observed in the brain by an anatomist, and the Greek word for almond is amygdala, and so that's where the amygdala gets its name. So it's a kind of nut in the brain, and we can ask ourselves, what does this nut do? The usual answer is that the amygdala is the brain's fear center. When you see a bear, you run from that bear, or you freeze because fear has been aroused in your amygdala. That is the common story. Now, the amygdala receives inputs from the sensory world and allows it to control freezing and running and all of these behaviors by way of these connections. We see that there's information coming into the eyes from the snake, going to the cortex where we normally have our perceptions, but also taking a shortcut from on the way to the cortex directly into the amygdala. So the amygdala is getting sensory information from the cortex, which allows you to simultaneously know what it is you're looking at, but also getting this shortcut information from the thalamus that allows you to respond to the snake before you know what it is you're looking at. So this is a rapid pathway that allows you to prevent yourself from stepping on the snake as you're walking down the path before you step on it and have it bite you. So if we look at this in terms of the visual pathways, we can see the amygdala on the two sides of the brain here. And by the way, there is one on each side of your brain. And so the information is coming in from the eyes. Each eye is going to each side of the brain, going to the thalamus and then the cortex. And then, as we just saw, getting inputs from the thalamus and cortex on each side, allowing you to respond to the danger before you know what it is, but also to know what it is that you've responded to. Now, the amygdala has at least a dozen different parts. Not all of them are involved in these kinds of behaviors. And even when they are involved, it's not that these parts of the brain are doing anything. A part of the brain is just literally a piece of meat. It doesn't do anything. The action, the work is being done by cells and synapses that are connected to other parts of the brain, that are connected to other parts of the amygdala, and the outputs go to even further parts of the brain. So we have to think of these functions not as phrenology. The amygdala is not a kind of place where anything is done. It's the cells and synapses and circuits that are doing the work. So the inputs coming in to this part of the amygdala called the lateral nucleus, which connects with the central nucleus, and then that controls all of these responses. So, and this is just saying the same thing here. The issue then is, what is the role of fear in all of this? And the usual answer is, as shown here, that a threat in the outside world, like a snake at your feet, arouses fear in the amygdala, and fear causes you to respond with a fear response. But this is what I think is wrong, and what I've argued in my book, Anxious, is wrong with the way we've been talking about all of this. That we shouldn't be talking about fear in the amygdala. Oops, there's something missing here that didn't work, but what this should be replaced with, what fear should be replaced with here, is what the amygdala is doing is detecting and responding to threats. This is not necessarily the same thing as fear. The ability to detect and respond to threats occurs unconsciously in your amygdala. The amygdala is not part of the circuitry that leads to conscious awareness. It's receiving information and responding on the basis of that information, but without any awareness of what's involved. So it was a great surprise a few years ago when a woman with amygdala damage was shown to still be able to feel fear. This led to big headlines in Nature, Wired, Scientific American, Discovery, all sorts of magazines. Humans can feel terror even if they lack the brain's fear center, scaring the fearless, and on and on. So in people, the feeling of fear clearly occurs when we're in danger. We therefore come to believe that these feelings cause the responses, because when we respond, we usually feel fear. But when we study the amygdala, we measure responses that are not necessarily causing, it's not that they're not caused by fear. This is an important confusion, and it's based on correlation rather than causation. We correlate our fear responses with our fearful feelings, and so we call them both fear, but really only one of them is fear, and that is the feeling. The responses coming out are controlled non-consciously. Your brain is detecting the danger and responding to it, and you aren't necessarily consciously participating in that. So here's the one we should have. So replace fear with threat detection and response control. So fear doesn't occur in the amygdala and doesn't cause the responses to the threats, and the amygdala is not the brain's fear center. So if the amygdala is not the brain center, where does fear come? Well, my theory has long been that fear is a product of neocortical circuits, the highest levels of the brain, that are able to put information together about the fact that you're in a dangerous situation. So there's information about the stimulus, for example, the bear. But in order to know what a bear is, you have to have memory about what bears are. Your brain doesn't automatically know what a bear is. You have to learn what bears are. So we are going to have information about the stimulus. We're going to have memories about what that stimulus is and that it's dangerous, going to come together. And in addition, the amygdala is going to be responding, and this will be generating signals in the body and brain that also feed into this circuitry and allow you to experience the danger and thus to experience fear. So the conscious feeling of fear, in my theory, that as laid out in my book, Anxious, occurs through neocortical circuits, the details of which I'm skipping here, whereas non-conscious responses are controlled by the amygdala. Now, one of the implications of this is for why drugs have not been more successful in helping to treat fear and anxiety. So Andrew Whitty, the CEO of GlaxoSmithKline, in 2010 said, "We believe the probability of success is relatively low." He was talking about the probability of success in developing new anti-anxiety drugs, and therefore the company was going out of the business. And several companies are going out of the anti-anxiety business because they think the drugs they've developed have failed. Scientists have concurred with this, saying that the clinical outcomes of these efforts have been disappointing. So let's talk about how these drugs are developed. These are standard tests that pharmaceutical companies and scientists use to develop these drugs. Let's start with the open field test. So you put a rat or a mouse into this area, and animals don't like to be in this kind of situation because in the open like this, a rat or a mouse is a prey, and so a predator can swoop down like a hawk and eat it. So what they do is they run to the sides and hide in the corners where they'll be more protected. So if you give the mouse a drug that makes him less likely to stay on the side and spend more time in the center of the area, that's viewed as making the mouse or rat less anxious. Therefore, it should make the person less anxious. But what you find is that when you give these medications to anxious people, for example, a person with the social anxiety disorder who is made upset by going to parties where lots of people are interacting, what is likely to happen in this case is the person is more likely to go to the party, but to still feel anxious. And that's exactly what's happening to the rat or the mouse here. The rat is more likely to go out into the open area. It's less timid behaviorally, but we don't know whether it's less anxious or not. But it's less timid behaviorally, and that's what the drugs are doing in people as well. So the conclusion here is that the anti-anxiety drugs are working here on these unconscious circuits that control behavior, but fear and anxiety are occurring here, and that's why the drugs are making the people less timid but still anxious when they're at the party. So it's a very simple idea. I think it has profound implications. For one thing, it suggests that we need to treat these two classes of symptoms, the feelings of fear and anxiety that people experience, and their behaviors in the presence of the same stimuli that make them fearful or anxious. Those two things are controlled by different brain systems and need to be treated differently, separately. So, this is basically what I've said. The drugs are basically doing what they were designed to do, but not what the pharmaceutical companies wanted them to do. So from the business point of view, the drug is a failure, but from the therapeutic point of view, it's not such a failure because it's helping people to a certain extent. If we know what these treatments are doing in the brain, we'll have a better way of understanding how to treat people, not only with drugs, but also with psychotherapy. So, our ability to understand the brain is only as good as our conception of what we're studying in the brain. Just because something is framed as science doesn't mean that it's correct. So even information conveyed by scientists can be wrong. A lot of my colleagues cling to the idea that the amygdala is the brain's fear center because it's a convenient way to talk about these things. It's very easy for the public to understand, but I don't think I'm having such a hard time communicating this concept to you. So I think it's important that some of my colleagues agree with me but don't want to change the language. But I think it's important that we change the language because the way we talk about these things not only impacts the way people understand it, but it also impacts how we get funded for our research and how our research is used in the treatment of people. So just to reiterate, the anti-anxiety drugs are working in these subcortical circuits that control behavior, but patients are feeling fearful and anxious up here. So these ideas are talked about in my book, Anxious, and in the companion CD, I have a band that plays music about mind and brain and mental disorders called the Amygdaloids, naturally. And this is also music in our CD. In the book, and I'm sorry I don't have the Italian version of the book here, but it is available here at the festival. In the book, in the preface, is a download code where you can scan the code with your smartphone and download the album. I don't have a song from the album, but I do have a music video called Fearing from one of our earlier albums, if we can run that, and maybe turn the lights down in the hall if you can. Can you lower the lights? No? Okay, well, we'll see how it goes with the...
basic emotion. It occurs when we encounter danger. An animal can put off the good stuff, eating, drinking, sex for days. But responding to danger must be immediate, or there will be no more eating, drinking, or sex. The fear response is the same in humans and other mammals. Muscles tense, heart beats fast, hormones flow. These responses help keep us alive when threats arise. If to fear were merry, and to
Can you pause? Can you pause for a second?
Recollecting's not forgetting. It's vivid rehearsal of pain. It reminds me of that day. It keeps fear in my brain. Evolution says if it ain't broke, don't fix it. Indeed, the brain mechanisms of fear are highly conserved. The amygdala is
I just wanted to say that this part is X-rated because it has my old theory in it.
And produces protective responses. The amygdala also forms emotional memories. It uses these to predict harm in the future. Fear learning is rapid and persistent. While fear memories can be controlled, they are hard to eliminate. The amygdala is hyperactive in many psychiatric conditions, some of which can be treated with drugs. Others respond better to psychotherapy. We need better treatments for fear. If recollecting or forgetting, then I remember not. If forgetting, recollecting, how nearly I forgot. But recollecting's not forgetting. It's vivid rehearsal of pain. It reminds me of that day. It keeps fear in my brain. It keeps me waiting, but not waiting in vain. It keeps me waiting. It keeps fear in my brain. It keeps me waiting. It keeps fear in my brain.
So, thank you very much. I'm done. Keep going. So, can we take some questions? Would anyone like to ask a question?
Adesso vi voglio vedere fare domande in inglese su questa roba qua, perché io non sarei in grado neanche di tradurlo, quindi se avete il coraggio... Vediamo qua, aspetta. Vado qui che è più vicina, poi arrivo da lei.
No, in your song, I noticed you were saying about recollection, that recollection keeps fear in your brain. So basically, remembering past fears. I would like to ask a question about that.
Yes, that's a very good question. So one of the things that happens when you're in a situation where there's danger is that your brain is active, your amygdala is activated, and one of the consequences of that is that hormones are released into the brain and body, and these will store memories that are present. So every time you retrieve a memory about past danger, you restore that memory in a stronger way because of the hormonal release during that time. Now, this has led to the idea that perhaps we might be able to treat people with troubling memories by blocking the restorage of the memory when it recurs. And we've done some experiments on this also all in animal models. Starting in the year 2000, we published a paper on this that is easiest to explain in terms of the movie The Eternal Sunshine of the Spotless Mind, which came out 4 years after that experiment. And basically in the movie, the main character is brokenhearted over a love affair and goes to a company that erases his memory. And the way the company does that is they have the fellow retrieve memories about the girlfriend, and each time he retrieves a memory, they zap his brain. So this is essentially what we did in the experiment. The rat was conditioned with a tone and a shock, so that when the rat heard the tone later in life, it would respond to the tone by freezing. But if we zapped his brain when he remembered the tone, in other words, we played the tone 3 weeks after he learned, if we zapped his brain as he was listening, after he listened to the tone, and then played the tone the next day, he no longer responded to the tone. So this is called the blockade of reconsolidation, because during the retrieval process, you restore the memory or reconsolidate it with all those hormones present and so forth, making it stronger. But if you block the restorage, and the way we did that was using drugs that prevent protein synthesis, because protein synthesis is the way memories are stored and restored. So if we block protein synthesis after the retrieval of the memory, then the memory no longer troubled the rat to the extent that the rat no longer would freeze in the presence of that stimulus. Now this has been tried in human patients with disorders, but one of the problems here is that in the experiment we did, what we were doing is blocking the restorage in the amygdala, not in the systems that give rise to our conscious memories. So it wouldn't have worked in the movie because the guy forgot about the girl. He no longer knew the girl. And so we've been asked many times to help people forget their memory of their ex-wife or girlfriend, but that's not what we're doing. What we're blocking is the restorage of these unconscious memories that control behavioral responses to threats, not the conscious memory. And so this, like drugs, may be useful in a therapeutic situation by dampening the emotional response rather than by erasing the memory of the situation.
Ok, un'ultima che era partita lì, posso farne solo una perché il tempo poi sta per scadere. Se l'era prenotata, avevo visto, però se vuole, va bene se non si offende. Okay.
So all nervous conditions are based on troubling memories. All anxious conditions. There has to be a troubling memory.
Are you asking or telling?
I'm asking.
Not necessarily, because let's take, even though the amygdala is not the source of anxiety in your brain, it can contribute to anxious feelings indirectly. So the point I'm making is not that the amygdala has no role in fear and anxiety, it's just that it is not the source of fear and anxiety. But the bodily responses and the hormones and all of that stuff that happens when the amygdala is activated are going to affect the conscious experience and the conscious memory. So, but I wouldn't say that every anxious situation is due to a memory necessarily, because some people are born with a kind of overactive amygdala that is either more sensitive to threats or more reactive to threats, as those are different things. And so a person may be simply responding more severely to a situation that other people don't respond to, and their responses would then be out of kilter with what so-called normal people do, and so they may seek help because of that. So, in other situations, you could have a response to a threat that you don't consciously know is present, but you respond to it. For example, if you have, if someone mugs you on the street some night, and that person is wearing a white ski cap or something, the next time you're walking down the street and someone has a white ski cap on, you might feel tense and anxious, but not necessarily know why, because your amygdala picked up that white ski cap because it was so encoded during that experience, but your conscious mind didn't necessarily focus on that. So that would be a memory, but it would be an unconscious memory rather than a conscious memory. So it's, nothing is black and white where it's all or none. There's always learning, there's genetics involved in all of these things. Some people are genetically more anxious than others. Some people are more anxious than others because of experience. And in both cases, it's the interaction of the genetics and experience that ultimately determines how anxious you are.
C'è lo spazio per una domanda brevissima, l'ultima. Sei a posto? C'è qualcun altro che... Una domanda brevissima?
Hi. So you were saying that we don't actually have a reliable way to study fear in animals? Because we have the threat study, like we can study threat reaction. Do you think there is some way to study it to see if they actually have fear?
No, I don't.
So it's actually like, kind of...
I think scientifically it's impossible to know. So here's the reason why. In people, we can present stimuli to a person subliminally. So the person doesn't know the stimulus is present, doesn't feel fear, but the stimulus will activate the amygdala and produce these responses, racing heart, muscle tension, sweating, and so forth. So if these responses are not a reliable indicator of fear in a human, how can we use them as a reliable indicator in an animal?
Solo che poi non la sentiamo. Velocissimo, battute, poi...
It's not a really good news for scientists. I mean, it's kind of...
Well, it's important that we know what we can and can't study as scientists. I think it's very important to understand how these responses are controlled by the brain, because that is an important factor that not only occurs in a threat situation, it also can feed into the anxiety that one is feeling. So we have to understand this. It's just not anxiety itself. It's an important part of it. But as long as we put anxiety in the amygdala or other parts of the brain that are not the source of the feeling itself, we're misrepresenting what it is we're studying. That's all I'm saying.
Bene, siamo arrivati alla conclusione di questo accento sdrucciolo e ringraziamo il nostro ospite con un applauso, ovviamente.
Thank you.
E vi ricordo che i libri del nostro ospite sono in vendita nel banchetto che c'è alla mia destra, sono in italiano e lui sarà felice di autografarveli. Grazie, a più tardi.